Okay, let's continue this. What I'm gonna do right now is go back to the book I was reading, and on that topic, I'm also gonna show you my tablet. I hope you like my new wallpaper. But let me open this up. All right. So we are taking the data, and it's time to start working on our project. We are being provided with some Jupyter notebooks. So we have some Jupyter notebooks here that we have been provided from this book that I'm following. We could also run them in Google Colab. We could run them in Kaggle. I don't know what this is. We should be working on the chapter 2 end-to-end machine learning one. I'm gonna remove this. So this is a Jupyter notebook, and it's composed of a list of cells, and each cell contains either executable code or text. So we can edit it, and we could also run it. Welcome to machine learning. All right. So these are basic things. I know this already. It's not something that is interesting to me right now. We have Python version 3.7. I hope we do. We need the science kit to learn. We don't have it. No module named this, so we need to install it. We need to install it. We get an error. Module not found. Module not found. sk learn. And this occurs mostly because we don't have this library in our Python environment. So we need to install it, and we can use pip. How can I install it? So what I can do is actually I can start an environment, go into this environment and install it there, but I don't want to do this. I want to do this directly from Visual Studio Code if it's possible. Terminal, new terminal. Okay, it's here. Pip and install science kit learn. I hope it's science kit. It's scikit. I call it science kit. Okay, it's gonna take some time. Are we done? We are. Okay. And now we installed scikit. Nice. Okay, so now we have the data. Yeah, just a heads up, because we are working in just a second. So we in order to run Python, we need to allocate a runtime, which is like a virtual machine located on our own computer, or in case if you're working with Colab, it's located on Google servers, and it's containing a bunch of tools and Python libraries, and it includes everything we'll need to work with this. Okay, so these notebooks are interactive, so we can run each cell one by one. We can insert a cell, we can play with the code, go back and run the same cell again. Okay, so we need to run the cells in the right order. This is something that's really important. Miss a cell, the subsequent code cells that depend on the cell beforehand will likely fail. All right, what else is said here? There are differences between the code in this book and the code in the notebooks. So I'm following a book. It's called Hands-on Machine Learning. So yeah, I mean, it's obvious. It's obvious. Well, the libraries might change, or maybe we have some extra code that's going to beautify the figures. All right. So now we need to get the data. Usually our data would be available in a relationship database or some other common data store. Okay. And it would be spread across multiple tables or documents or files. But in our case, we need a single compressed file, which is called housing.tgz, and it's gonna contain a comma-separated values file called housing.csv with all the data. Do we have this file here? Do we have this file here? Maybe not. Maybe we'll need to download it. Let's make sure. Ah, here it is. Here we have here we have a function already written for us that downloads and decompresses the data. This is actually useful if the data changes regularly, and you can write a small script that uses a function to fetch the latest data, or you can set up scheduled job to do that automatically at regular intervals. So what do we have here? Here we have the logic that fetches and loads the data. So we are calling this method named load housing data. Inside of this, we are looking for a path for datasets slash housing TGS. If we don't find it, we create a datasets directory. We download this file here, and then, so while this is open, we extract all, and then we load this CSV file into what? Into a Panda data frame object, which contains all the data and returns it. So I have a question here. What is a Panda data frame object? So let's run this. No module named pandas. We also need to install it. New terminal, install pandas. While this is building, I took a look on Google on what a pandas data frame is, and it's a two-dimensional tabular data structure in Python that's similar to an Excel spreadsheet. So I assume this is just a way of representation of Excel spreadsheets in Python. So it has rows and columns, it has labeled axes, and support various data types. It has some powerful operations. All right. So if I run this again, and if I remove this, so it's taking some time. It's already running. Okay, all right. And now, if I have housing head, okay, this is the data structure. What's the type of this data frame? So we are looking at the top 5 rows of data by using the data frame's head method here. So we have a longitude property column, a latitude column, median age of what? Of the house, total rooms, we have some income, we have some data. To be honest, I don't know properly what they mean. I mean, I know that each row is a district, and we have 10 attributes. All right. Now we also have the housing.info method, and this one is useful for getting us a quick description of the data. So that's it. The total number of rows, each attribute type, and the number of non-null values. How many instances do we have here in total? 20,640 instances in the dataset. One thing I noticed is that the total bedrooms property attribute has only 20,433 non-null values, meaning that we have some data missing for the feature, and we're going to take care of this later. So all of them are float 64 types, except for ocean proximity attribute. It says that the type of it is an object, so it can hold any type of Python data, but since we loaded this data from a CSV file, we know that this must be a text attribute. And where is ocean proximity? It's here. So we have same data here. Because we have same data, it's probably a categorical attribute, and we can find what categories exist and how many districts belong to each category by using the value counts. But wait, can I run only clear all outputs? Yeah, this is what I wanted. Clear all outputs, and now I only want to run these above. Okay, now I'm gonna run each one separately. So housing info has this data. Now ocean proximity, we are using the value counts method, which will group the districts based on category by using this method. What else we have? We have the describe method. The describe method shows a summary of the numerical attributes. So this is how many attributes we have. This is their mean value. The minimum values. The maximum values. What is standard? The standard row shows the standard deviation, which measures how dispersed the values are. So the standard deviation, or STD, is a measure of how spread out the values are in a dataset, which means that a low standard deviation means that the values are close to the mean, and there is less variation, which I assume is true for longitude and latitude, because most of the properties of the districts are centralized in a relatively narrow area of San Francisco. So this is why the standard deviation is quite small. But the high standard deviation means the values are more spread out. Like here, we have the value of total rooms, total bedrooms. Population is highly spread out. Why is this so small? All right. And we also have a formula for standard deviation. I won't go into it now. So actually the standard variation describes how much the values are spread out from the mean. So on average, a standard deviation of 2 says, okay, we have values spread around 2 from the mean. And here, most probably, we will have a more dispersed variation. All right. So what are the 25, 50, and 75%? The 25%, 50%, and 75% rows show the corresponding percentiles. A percentile indicates the value below which a given percentage of observations in a group of observation fall. I don't understand this. Let me find a better explanation. Maybe ChatGPT can help me. So when we run describe, you see the 25, 50, and 75% rows. These guys. They represent the percentiles of the dataset. A percentile indicates the value below which a given percentage of observation falls. So how is this working? So let's say, for example, we have salary data, and we have 50,000, 55,000, 60,000, 70, and 80,000 values in the salary array. So what I assume the mean would be So what I assume the mean would be the sum of all of these values divided by 5. And I won't calculate this on my own. I think it's going to be 63,000. Right. Now, what is the 25% property saying? So it's the first quartile. Which means 25% of the salaries are below 55,000. So if I represent the data like this, 25 out of so it means that 25% of the salaries are below 55,000. Now we have 50%, and here it says it's the median, which is the second quartile. 50% of salaries are below 60,000, which makes sense because we have two of these here. And also, if we take out 55%, 25 is 1/4. We have only five values, so 1 out of 5 is 25%. Next, 75% is 70,000, so it means 3/4 or 75% of salaries are below 70,000. So why is this important? Because it helps us understand data distribution, and it's used to detect outliers, and we get a lot more informative data. So here it says we have 25% of housing median age is less than 18, and 75% is 37 or less. So 75% of houses are at least 37 years old. I assume the median age is represented in years here. Interesting. Okay, so there's another way to feel the type of data that we are dealing with, and that is a histogram that we can plot for each numerical attribute. And a histogram shows the number of instances on the vertical axis that have a given value range on the horizontal axis. And we can plot this attribute one at a time, or we can use the HIST method on the whole dataset. This cell is not shown in the book. Yeah, it creates the images and to the end-to-end project folder. All right, this is only an image of California. And it defines a save figure function, which is used to the notebook to save the figures in high resolution for the book. All right, so this is the path. We create an images folder, we create end-to-end project. Here, this is the method. We have a figure ID, tight layout, no idea what this does. It's PNG, resolution. So we have a figure ID dot figure extension. Okay, now it seems that we can't plot anything because we don't have this module, which we are going to install right now. We are going to do this. No, I don't want to debug. I want to install a new rule. Yeah. So if we run this, what should do? If we run this, what should happen here is that we should plot a histogram for each numerical attribute. So I would assume these are data. These define the default font sizes. Again, I'm far from an expert on machine learning, so I assume the first 5 lines are configuring matplot appearance. I don't have an idea what RC means, but I assume this sets the font size, this sets the label size, which is again, I think font size is also font size, font size, font size. Now this plots the histogram for the housing dataset. So bins equal 50. It's gonna split the data into 50 bins for better granularity. And in the end, we are seeing the figures. Now, if I run this, it should work. Alrighty. So this is how the longitude data is mapped. Latitude, age. I don't get this one. Wait, where's the 7th age? So 75% of houses should be younger than 37. All right, I don't know if this is an outlier or if this is some erroneous data, but we have a lot of houses that are 50 years old or older. Total rooms, total bedrooms, population, median house value, households. All right. So what do we have here? We have the median income attribute, and the book says it does not look like it expressed in US dollars. After checking with the team that collected the data, you are told that the data has been scaled and capped at 50 for higher median incomes and at 0.5 for lower median incomes. And the numbers represent roughly tens of thousands of dollars. So this 5 actually means $50,000, I assume. All right, so we have some pre-processed data, and the book again says it's pretty common to have pre-processed data, but you should try to understand how the data was computed. And you're gonna do this. What else is kept? The housing median age here, and the median house value. Ah, this is what it means. That's why our data is not that precise. Because what happens is probably our machine learning algorithms may learn that prices never go beyond that limit. And we need to check with our client team to see if it is a problem or not. So if we need more precise predictions beyond, for example, the house value that is more expensive than 500,000 US dollars, then we have two options. We need labels for the districts whose labels were capped, or we need to remove those labels from the training set and also from the test set, because we can't properly predict values that are bigger than 500,000. Nice. Now we need to create a test set, and we can do this in the next episode. Thank you.